So hi everyone. Today we will learn a very special technique by which you can load big LLMs which might not be able to fit in your memory by using quantization. So basically this would be a great tutorial if you want to load a big model which you can't load in general settings in your local system or on Google Colab. So we will be using quantization to load these models into your Google Colab notebook or be it your local system. So let's get started. So we would be loading Quint 2.5 Coder 7B Instruct. So I tried loading it with general settings in Google Colab. It was able to load, but inferencing was super slow. I think it took me 30 to 40 minutes to inference a single output. Now in this particular use case, we would be using quantization, bits and bytes config to load the same model, and then eventually we will see how it performs. So first of all, you need to pip install, upgrade torch, transformers, accelerate, bits and byte. So basically you need to upgrade transformers. Do remember this, and bits and bytes and accelerate are important here. Then we will be importing some important configs including bits and byte. So basically in a general config, what we do when we are loading a model directly from transformers, we use this particular template. Auto model from causal LM from pre-trained model name, device name map is auto, and trust remote code equals to true. Now in case of quantized model loading, we would be using one more parameter, quantization config, which we would be coming from bits and bytes. So basically what quantization does, it helps you to load your weights. So for mostly the weights that are trained are of 16 bit or of 32 bits usually. So because of that they acquire a lot of memory. Now eventually for loading them into hardware or where we don't have much resources with us, you can load the same weights into 4-bit quantization. By 4-bit now, the number that was used getting the weight that was getting represented by 16 bits or 32 bits in the memory earlier now would be represented by just 4 bits. So now if you have 2 billion parameters, for example, so instead of 32 into 2 billion, it would be 4 into 2 billion. So now you can understand how the size would differ a lot. Now our only demerit is that it might take a slight hit on the quality of the output as well, but the hit won't be that major, I assume, and hence can be a go-to solution if you are restricted hardware. So in this quantization config that we are setting up in bits and byte, you need to mention load and 4-bit is true. BNB 4-bit quant type equals to NF4. So basically this is one of the quantization, normalized 4-bit, and 4-bit compute D type torch.bfloat16. So basically we would be using bfloat16 for computation that would be going inside. So this config we would be adding up while loading the model. Everything else remains the same how you load a model from transformer. So this is the model that I'm using, Quint 2.5 Coder 7B. Auto tokenizer we have loaded, and auto model from causal LM we are loading the model Quint 2.5 and mentioning this quantization config here, right? Everything else remains the same. For your reference, in the comment I have added the general config, that the general method how we load the model and how the quantized model is getting loaded. That's the only difference. There's 4 lines. The model gets loaded quite quickly. I'm not demonstrating it in front of you in this particular video as it will take some time, but the loading time was way faster as compared to the general loading, and even the inferencing was super fast, right? A quick sort algorithm. Everything remains same how you do it using transformers, tokenizer, then model.generate, and then decoding the tokenizer. That's it. The response would be very quick, and you should be able to load now decent in a big enough models, like even 11B or 12B models you can try out by using quantization because it should work. 7B coder was not working on Google Colab. It was taking very long inference time. It took me around 30 minutes, as I already told you. But in case of quantization, it took just 2 to 3 minutes for inferencing. So do try it out. I think quantization is a very important concept, and eventually in the coming videos, I would be deep diving into quantization a lot. Thank you so much.